Hello and welcome everyone. I am Kashish Ahuja, a student of the International Institute of Professional Studies DAVV Indore, pursuing Integrated MTech IT, currently in 8th semester. This video is for my cloud computing assignment completed under the guidance of Dr. Vivek Srivastav on the topic Deploying an Application on AWS EC2. So, without any further ado, let's get started. Before directly jumping into practical deployment, let us first get some basic theoretical knowledge. Cloud computing. Cloud computing is the on demand delivery of IT resources over the internet with pay as you go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as cloud computing power, storage, and database on as needed basis from a cloud provider like AWS. Cloud computing characteristics. The National Institute of Standards Technologies (NIST) lists five essential characteristics of cloud computing. On-demand self-service. With cloud computing, you can provision cloud computing services like server time and network storage automatically. You won't need to interact with the service provider. Cloud customers can access their cloud account through a web self service portal to view their cloud service, monitor their usage, and provision and deprovision services. Broad network access. Another essential cloud computing characteristics is broad network access. You can access cloud services over the network and on portable device like mobile phones, tablets, laptops, and desktop computers. A public cloud uses the internet and a private cloud uses a local area network. Latency and bandwidth both play a major role in cloud computing and broad network access as they affect the quality of service. Resource pooling. With resource pooling, multiple consumers can share physical resources using a multi tenant model. The model assigns and reassigns physical and virtual resources based on demand. Multi-tenancy allow customers to share the same application or infrastructure while maintaining privacy and security. Though customers won't know the exact location of their resources, they may be able to specify the location at a higher level of abstraction, such as country, state, or data center. Memory, processing, and bandwidth are among the resources that customers can pool. Rapid elasticity. Cloud services can be elastically provisioned and released, sometimes automatically, so consumers can scale quickly based on demand. The capabilities available for provisioning are practically unlimited. Customers can engage with these capabilities at any time in the quantity. Customers can also scale cloud use capacity and cost without extra contracts or fees. With rapid elasticity, you won't need to buy computer hardware. Instead, you can use the cloud provider's computer computing resources. Measured services. In cloud systems, a metered capability optimizes resource usage at a level of abstraction appropriate to the type of service. For example, you can use a measured service for storage, processing, bandwidth, and users. Payment is based on actual consumption by the consumers via a pay for your use model. Monitoring, controlling, and reporting use creates a transparent experience for both consumers and providers of the service. Types of cloud computing. The three main types of cloud computing includes infrastructure as a service, platform as a service, and software as a service. Each type of cloud computing provides different levels of control, flexibility, and management so that you can select the right set of services for your needs. Infrastructure as a service. It contains the basic building blocks for cloud IT. It typically provides access to networking features, computers, virtual or on dedicated softwares, and data storage space. It gives you the highest level of flexibility and management over your IT resources. It is most similar to the existing IT resources which many IT departments and developers are familiar with. Platform as a service. It removes the need for you to manage underlying infrastructure, usually hardware and operating system, and allows you to focus on the development and management of your applications. This helps you to be more efficient and as you don't need to worry about the resource procurement, capacity planning, software maintenance, patching, or any other heavy lifting involved in running your application. Software as a service. It provides you with a complete product that is run and managed by the service provider. In most cases, people referring to software as a service are referring to end users' applications such as web based emails. With software as a service offering, you don't need to think about how the service is maintained and how the underlying infrastructure is managed. You only need to think about how you will use this particular software. Now that we know about cloud computing, let's understand a bit about the cloud provider and its services that we will be using for the deployment. AWS. AWS stands for Amazon Web Services. It is a cloud computing platform including a mixture of infrastructure as a service, software as a service, and platform as a service offerings. EC2. EC2 stands for Elastic Compute Cloud. Amazon EC2 is a service offered by AWS that provides scalable computing capacity in the Amazon Web Services cloud. Using Amazon EC2 eliminates your need to invest in hardware upfront so you can develop and deploy applications faster. You can use EC2 to launch as many or as few virtual servers as you need, configure security and networking, and manage store. Amazon EC2 enables you to scale up or scale down to handle changes in requirements or spikes in popularity, reducing your need to forecast traffic. Now that we have basic understanding of cloud computing, AWS and EC2, we are ready to learn on how to deploy applications on AWS EC2. Here are some easy steps you can follow to deploy your application. First, log into the AWS console. Second, navigate to EC2 service. Third, click on Launch Instance to create a new EC2 instance. Fourth, set up your instance by configuring your virtual machine. This includes selecting an Amazon Machine Image AMI, choosing an instance type, configuring instance details, adding storage, configuring security group rules, and launching the instance. Fifth, once the instance is launched, connect to it via SSH using a terminal or a SSH client. Sixth, install the required software packages on EC2 instance like Git and Node as we will be deploying a MERN stack application. Seventh, upload your project to the EC2 instance. Eighth, install the project dependencies using npm. Ninth, start the server of your application using an appropriate command such as npm start. 10th, add the specified port of your application to the security group of instance. 11th, now the application will be running on public IP address. 12th, terminate the instance if you no longer wish the application to be deployed. Now that we know all the steps of deploying an application, let's practically implement our theoretical knowledge and deploy an application on AWS EC2. I have already logged into the AWS console. You may do the same. In recently visited, I am getting EC2, so I can directly navigate to EC2 from here. If you are trying it for the first time and you are not getting EC2 in your recently visited, you can click on the services on the top, go to compute, and from there you can select EC2. After navigating to EC2 console, you can click on launch instance. These are some of the configurations that you need to do to create an instance. Give an appropriate name to your instance. Select an OS that you would be needing for your virtual machine. I'll be going with Amazon Linux. You can also select the architecture and the different types of instances that are provided. There are different types of instances like micro, nano, small, etc. As I am having a free tier account, I'll be going with T2 micro, that is free tier eligible. You need to create a key pair login. You can also use an existing one, but I am creating a new one. Save the key pair to your device. These are some of the network settings. This lets you decide from where you are allowing the traffic to your deployed application. The configure storage settings, this lets you decide what amount of storage your virtual machine needs. You can also add new volumes of storage if you require, and you can configure some advanced settings from here. After configuring all the settings, you can create on launch instance. It will take a few seconds to create and launch a new instance. After successfully uh, After successfully launching an instance, you will see a pop-up alert box to that your instance has been launched successfully. In case your instance has failed, you can also see the launch log to see where it has gone wrong. Scroll down and go to view all instances. As we can see, our cloud computing assignment instance has been successfully created and it is running. The next step is to connect to an instance. To connect to an instance, select the instance you want to connect to, and on the top you can see the connect button. You can also name a user. You can also create a custom username for your user. I am fine with EC2 user, so I'll be continuing with that. On clicking connect, it will redirect me to my virtual machine, the instance that I just now created. It will take a few seconds to establish the connection. Now we can see the connection has been established. Once the connection has been established, we need to install the all the software packages that we will be using. As I'm using Git for storing my project, I'll first need to install Git. For that, let us first check the version of Git if it is already present. As we can see, Git command is not found because Git is not already installed in my machine. So I'll be installing Git with this command. It will take a few seconds, and if it will ask me if the size of the installation is okayed by me. Once I can see the complete, I can again check the version of the Git. This time I'll be getting the version of the Git that has been installed on my machine. As I can see, Git version 2.39.2 is been installed. I will also be installing Node as I'm deploying a Monstack application. You can first check the version of the Git by node-v. As you can see, the node is also not present in my virtual machine. So to install the node, this is the command. It will take up to few seconds to install the node. And once I see complete, I can check the version of the node. As you can see, the current version of the node installed is 18.12.1. After installing the both Git and Node, I can upload the project into my virtual machine. I have already uploaded my project into my GitHub account. For that, I can now go to my project and clone this project into my virtual machine. For cloning the project, this is the command git clone and then the link of your virtual link that you just copied. After cloning the project, I will need to start my application. But before that, we need to download all the dependencies that are required for the application. As you can see, my project has been now cloned into the machine. I'll move to the I'll move to my project repository and with npm install, I'll install on all the dependencies needed for my project. The installing of dependencies can take up to a minute depending upon the volume of the dependencies that your project requires. Now that we can see all the dependencies are downloaded, installed, these were the dependencies needed for the front end part of the project. I also need to install dependencies for the backend part. So I'll switch into the backend folder and install the dependencies for the backend part. After installing all the dependencies required for both front end and backend, I'll start my server by using a command npm start. Now we can see that our app is running on port 8000 and it is connected to all the connected to MongoDB Atlas that we are using for MongoDB. Our application is now deployed on our public IP address, which we can use as a link to see our application. Oh no, but this site can't be reached. Why is it happening so? This is because our application is currently running on port 8000, but we have not yet specified our application to take traffic from the port 8000. So we will just copy our port and we will move to the instance part. In the current instance detail, scroll down, you can see the security. Here we need to add our specified port to the security groups. So for security groups, we can edit the inbound rules. Here we can see all the inbound rules that are currently present in our security. From here we can see edit inbound rules. By editing inbound rule, I can add another rule that is for custom TCP. My TCP is 8000 port and I'll set it from to take this for it to be the source from anywhere, saving the rules. Now if I'll go to my security instances again, I can see that the custom TCP security group has been added to my inbound rules. Here, custom TCP 8000 port 8000 has been added to the security rules. Now if I'll again reload the site, as we can see that our application has been deployed now and it is completely working properly. So after that, the last thing is that you can terminate your instance once it is no longer in your use. For terminating your instance, you can just select the instance that you want to terminate, click on instance state and click on terminate instance. It will ask you to confirm, and once confirmed, it will take a few seconds. As you can see it is shutting down, and after a few seconds, it will be the instant state will be shown as terminated. These are a few resources I used for my video assignment. You can refer them to for a better understanding. I hope I was able to explain you well. Do let me know if you have any questions. Thank you.